Good evening. Welcome to the QCIS channel. Where on this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and what I'm going to present to you tonight is some basics that you are going to need if you're taking any type of science, such as physics, chemistry, biology, or if you're doing any type of conversions. And what I mean by conversions, I'm talking about, say, if you're out there in construction and you get concrete that's going to be poured, and you're given cubic feet. Well, when I look at my items quantity sheet, the item is not in cubic feet, it's in cubic yards. Well, how do I convert that? First of all, how do I get the cubic feet? Well, I'm going to do length, width, and depth. And then I'm going to get my cubic feet, but I have to convert that to cubic yards. So how am I going to do that? Very simple. Divide by 27. You remember something. 3 feet equal 1 yard. What about inches? Suppose I'm given a diameter, and you're going to see a number of these problems, particularly when you get into fluid mechanics, where you're given a diameter of pipe, and you want to come up with the flow rate. Now, your flow rate is generally in cubic feet per second. And you're also given a velocity in feet per second. Now, the bottom line is that diameter. I have to convert that diameter. I could be given an 8-inch pipe. So to find the area of that 8-inch pipe, I'm going to have to do something. I need to convert the inches into square inches. Now, how am I going to do that? Well, first of all, you need to find the formula for the area of that pipe. And anything circular is basically going to be, for your perimeter, it could be pi r squared, it could be 2 pi r. But for the pipe, when you're given a diameter, it's going to be pi d squared over 4. So if I'm given 8 inches, I'm going to take pi times 8 squared divided by 4. Now, that's going to give me square inches. But now, how do I convert that into square feet? Very, very simple. So if I have anything by square inches to get square feet, I'm going to either divide or multiply by 144. And this is how conversion factors work. And if you are doing some chemistry problems where you're going to have grams and moles, you're going to be doing some canceling. Now, it's very important because when you take tests such as the fundamentals of engineering examination, or if you're taking tests in your regular courses, you're going to have to convert and cancel items. Now, canceling items also does not mean just going from English units to English units or SI units to SI units. You might have to go from cubic centimeters to an inch. So what I'm going to do, I'm going to present something to you. And I love presenting my PowerPoints here. And we're going to deal with conversion factors and unit cancellation. Conversion factors and unit cancellation. I would take notes on this because you will learn something. Now, first of all, a physical quantity must include the number plus a unit. Now, what do I mean by a number plus a unit? Okay, let's talk about gallons and ounces. Well, ounces is the unit and the number is 128. That's what we mean when we're dealing with physical quantities. Unit conversion. 1 foot equals 12 inches. This is what we're talking about. You have a foot. That's physical. 1 foot. 12 inches. Well, how do we get that 1 foot? Well, right here, we're just taking 1 foot and we're converting it to inches. So 1 foot over 12 inches, that's going to give you 1 foot. 1 foot equals 12 inches. See, now when you, now, and also you may have to go back from feet, centimeters, centimeters to feet. Now, the way it's written numerically, 1 foot equals 12 inches. They have it written over here, 1 foot over 12 inches. You may see that written as well. "12 inches, 1 foot." Now, you have calculators that can do that for you, but it's best that you learn it long-handed. And it's very important because when you do calculations with unit conversions, you're going to be utilizing forces, you're going to be utilizing distances, you're going to be utilizing densities, liquids like gallons, you're going to be dealing with pressures. And if you don't know how to do the units, you're not going to get the answers right. Now, something else you might deal with too. You're going to deal with area. You're going to deal with miles. This is all going to come into play with unit conversions. Let's look at this one. Conversion factors. 1 foot is 12 inches. 12 inches equals 1 foot. Now, if I multiply these together, what's going to happen? And what am I going to get? I'm just going to get 1. Now, why am I going to get 1? Well, because the feet are going to cancel and the inches are going to cancel. So when I get 1 what? It's just 1. It's unitless because the units cancel. Let me show you how this works. All right, conversion factors. You have 3 feet, and I want to convert 3 feet into inches. So what am I going to do? Well, very simple. I'm going to look at these conversion factors up here. So I'm going from feet to inches, so I'm going to multiply. So I'm going to use this factor right here, 12 inches over 1 foot. So when I plug everything in, 3 feet, 12 inches over 1 foot, I'll multiply 3 times 12 and I get 36 inches. And what happens to the feet? They cancel. And you know you're doing it right when everything cancels. How many centimeters are in 1.32 meters? Now we're in SI units right now. So right now, equality, 1 meter equals 100 centimeters, or if you really want to get down to business, 1/100th of a meter equals 1 centimeter. Let's plug it in. So you have X in centimeters. So what I want to do is convert meters to centimeters. So what am I going to do? Well, I'm going to use this factor. I'm going to take 1.32 meters and I'm going to multiply it by 100 because 100 centimeters equals 1 meter. So once I plug everything in the equation, what happens to the meters? They cancel and I end up with centimeters. And we use the idea of unit cancellation to decide upon which of the two conversion factors we use. Show it to you again. How many meters is 8.72 centimeters? Again, 1 meter equals 100 centimeters. So the applicable conversion factors are, we have 1 meter to 100 centimeters or 100 centimeters to 1 meter. So we have centimeters. So we're going to meters. So now what are we going to do? We're actually going to divide this time. So I'm going to take 8.72 centimeters divided by 1 meter over 100 centimeters, and then I'm going to get 0.0872 meters. What happens to the centimeters? They cancel. This is how this works. And this is what you're going to see in physics. You're going to see a lot of these problems. Know your conversion factors. Now, how many feet is 39.37 inches? Well, you think about it. 1 foot equals 12 inches. So again, the applicable conversion factors are 1 foot to 12 inches or 12 inches to 1 foot. So what are we doing here? We are going to convert inches to feet. So therefore, I take 39.37 inches and I want to go to feet. So I know 1 foot, that's what we're going to come up. Something you need to know. The unit that you want to end up with is always going to be in your numerator, and your unit that you want to cancel is going to be in your denominator. Understand that. Whether the fraction is, now think this over now. The fraction can be a proper fraction where you have a smaller numerator over a larger denominator, or it can be improper fraction. Now, something else you need to know. If it's an improper fraction, you're going to be multiplying. Let's say if I'm going from feet, where you end up with an improper fraction, 12 inches over 1 foot. But right here, actually, when you go 12 inches over 1 foot, that's an improper fraction. But when you are going the other way to the feet, now it looks like the whole numbers are small when you're going from inches to feet or from centimeters to meters. Now, when you're going the other way from feet to inches, the whole number is going to be larger. Let me explain to you. Okay, like right here, 39 in actuality is larger than 3. So I start at 39.37 inches and I end up with a smaller whole number at 3.28 because basically I'm dividing by 12. Now, when I go the other way, by way of using the improper fraction, I'm going to multiply by 12. That's my way of looking at it from an applicative sense to make it easy for me. Again, when you work mathematics questions, sometimes you may come up with your own shortcut. The bottom line is, can you get the answer that they're asking? Like this one, 39.37 inches. What we want to do is convert that to feet. So here's how I'm going to do it. To convert 39.37 inches to feet. I know that 1 foot equals 12 inches. So what am I going to do? I'm going to divide 39.37 inches by 12 inches, and I get 3.28 feet. Now, what happens to the inches? They cancel because I'm going from inches to feet. Let's try another problem. Now we're getting into some lengths now, kilometers, meters, miles. So how many kilometers is 15,000 decimeters? Now we're dealing with SI units now. So you have to look at the problem very carefully. And sometimes you may have more than one conversion factor. So you're going to have to cancel twice. So I have decimeters. Now, anything that's deci, that's 1/10. This is what makes the metric system much easier than the English system. So I have 15,000 decimeters. So what I want to do is get to meters first. So what I'm going to do is I'm going to divide by 10. So now I have meters. So my decimeters cancel. Now I'm not finished because I really want to get to kilometers. But sometimes I have to go through meters to get to kilometers. So I'm starting off with decimeters, but I want to get to kilometers. So I've already canceled decimeters. So now I'm in meters now, but I want to get to kilometers. So I'm going to cancel again because I know 1 kilometer is 1,000 meters. So what happens? The meters cancel and we get 1.5 kilometers. And what happened? We canceled twice. And that will happen with some of these physics problems. Sometimes you may have to cancel 3 times. You may have to convert from days to weeks to years, but it all works out the same. Look at this one right here. How many seconds is 4.38 days? Well, what if I don't know? Well, you can apply a little common sense. You know, 1 day is 24 hours. 1 hour is 60 minutes. And 1 minute is 60 seconds. Let's apply it. And I guarantee it will work. So I'm given this problem in days, but I want to go to seconds. So with 4.38 days, I'm going to convert to hours first. So 1 day is 24 hours. So the days cancel. Now I'm in hours, but I'm not finished. I need to break the hours down into minutes. So 60 minutes equal 1 hour. So the hours cancel. So now I'm in minutes, but I'm still not finished because I want to get to seconds. So I know 1 minute equals 60 seconds. So I'm going to multiply 60 seconds over a minute. And the minutes cancel. And now you are left with seconds. So we had to cancel units 3 times. And sometimes you may have to do that. And if you cancel the units correctly, you should never come up with the wrong answer. Now come up with 378,432 seconds. Now, they also put it in what we call scientific notation. I'll do a video on that later on, where they take 3.78 times 10 to the 5th seconds, which is the same as 400, almost 400,000 seconds. And I'll tell you how they got that in my next video. I'll do scientific notation. Again, you have chemistry. You get factors in chemistry. And one of these days when I get everything up and going, I'll do chemistry problems for you. But this is what I do in construction. We're going to measure dimensions of a rectangle. So we're given a length of 9.70 centimeters and a width of 4.25 centimeters. So what am I going to do? I need to find the area of a rectangle. All right, what is the area? Area is length times width. So I'm going to take the length of 9.70 centimeters and I'm going to multiply it by 4.25 centimeters. And I have 41.2 square centimeters. Centimeters times centimeters is centimeters squared. Now, we have that number, but we're going to convert it into something. We're actually going to convert centimeters to square meters. Now, here's something that they did wrong here. We're going from square centimeters to square meters. So here they multiplied it by, we're going to meters. Here they have the wrong fraction in here. We're not going to meters, we're going to square meters. So this answer would be wrong. You must recall that 41.2 centimeters equals 41 centimeters times centimeters. So let's go ahead and break that down. Meters squared. You can break it down like this, centimeters times centimeters, and then multiply it by 1 meter over 1 centimeter twice. You can do that. Or 0.0001 centimeters. That will give you the same thing, but this is a much easier way to break it down. Or instead of doing that, you can break it down this way. In parentheses, you can square 1 meter over 100 centimeters squared. And one thing about math, and this is why I became an engineer that I enjoy, it's because you can take different ways to solve a problem. The first way that this problem was calculated was incorrect. But the second and third way, I will accept if I was grading papers. You find out which is easy for you, but you need to understand the procedures. And that's what you have here. And you're going to see these kinds of factors in dynamics. You're going to see them in some word problems. You're going to see them in a lot of engineering problems. Now let's go to millimeters squared. So let's recall 41 square centimeters, 41.2 square centimeters is 41.2 centimeters times centimeters. So they're doing it the same way. I'm going to go 41.2. You can take the centimeters and you can break it up and multiply it by 10 millimeters over 1 centimeter twice. Or you can just go ahead and take 41.2 square centimeters and just square 10 millimeters over 1 centimeter. Again, you can do it this way, because if you do it this way, you're actually seeing how everything is multiplied. And it can also make, if you're not confident, it can help you calculate without making an error. Sometimes when you square things in parentheses, you can make errors. Of course, they have calculators to do all that work for you, but you need to learn it by hand so you can be confident with it, because what if you don't have a calculator? So again, you can do it both ways, but either way, you're going to get the same answer. Now that is, we're dealing with millimeters. Now what we use millimeters for? Liquid. What about if we're working with solids, the volume of a solid? So we have a length of 15.2 centimeters, a width of 3.7 centimeters, and a height of 8.6 centimeters. Find the volume of the solid. Now, take 15 centimeters times 3.7 centimeters times 8.6 centimeters, and you get 480 cubic centimeters. So we're going to do something with that. We're going to convert to cubic meters. So the same way, and this is what I love about math, because now you can break it down 3 ways. You can take the centimeters and multiply it out 3 times, and then you can utilize the fraction 1 meter over 100 centimeters 3 times. That'll cancel everything out. That'll cancel the centimeters out. Or you can just take the 1 meter over 100 centimeters and cube it, and you're going to get the same answer. Or something else you can do. You can take the 1 cubic meter and then multiply by 100 cube, and you'll get 1,000,000 cubic centimeters. But either way, the cubic centimeters will cancel, and you'll get cubic meters. Measured dimensions of a rectangular solid. You have your length, they give you meters right here. 15.2 centimeters equals 0.152 meters. 3.7 centimeters equals 0.37 meters. 8.6 centimeters equals 0.86 meters. How do they do that? Well, basically, they divided by 100, and 100 just moved the decimal point over 2 places. And when you multiply everything together, you get 0.000480 cubic meters. Now, if I wanted to put this in scientific notation, it would be 4.80 times 10 to the negative 4, which I will explain to you how scientific notation works in another video. Convert to millimeters cubed. Well, by what factor do millimeters and centimeters differ? They differ by 10. Again, this is what makes the metric system a lot easier. You use factors of 10. 1 centimeter equals 10 millimeters. 1 square centimeter equals, everything is 100. And then cubic centimeters, everything's 1,000. But if you really want to make it right, 10 cubed is 1,000. 10 squared is 100. And all of these equal. And that's how everything works with the conversion factors. Now, conversion factors are very, very, very important. Matter of fact, I will try to do some in the future. And I'll show you how everything works. And now, with chemistry equations, mathematical equations, and I'll explain to you how I got those equations, because there are other units that I did not mention. There's kilograms, meters per second. Now in physics, that's a Newton. Then you have, I believe you have pound feet, pound foot per second. And that's a slug. You don't hear that term. That's an English term. And then you have a kip, a kilopound, which you use in structural engineering. I'll get to some more of those advanced conversion factors in the future. But that concludes the topic on conversion factors and cancellations. If you like what I just presented, please comment, share, and subscribe. And if you are looking for some political and social content, check out my main channel, the 411 Talk Zone radio show channel. And here's where you can find me. For the 411 Talk Zone radio show channel, you can find me on YouTube, X, formerly Twitter, Rumble, and Truth Social. And for the QCIS channel, you can find me right here on YouTube, X, formerly Twitter, and LinkedIn. And what I'm doing, I'm basically shifting all my videos here. I was doing them on Wednesday and Thursday. I believe I'm going to do them either Friday, Saturday, Sunday. Much easier. I don't have to get up the next day and work, and I can give you a better product. And once again, thank you for viewing and listening to this topic on unit conversions and cancellations from the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Until next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.